Hello, everyone. Thank you for coming to this talk. If you are here, probably you are React developers and probably you are dealing with OpenAPI Generator. So let me give you a little bit of an idea what we're going to talk today. So based on some research on open source project that you can find on GitHub, the most common way of integrating OpenAPI Generator within React application is this. And there are some limitations in this approach, although it's quite solid and it works. But first of all, we can see there's a lot of boilerplate code just to fire an HTTP request. And the elephant in the room is that most of the people use new instances of the API clients that are automatically generated. And this can be heavy on the memory, on the heap of the JavaScript runtime. So instead, today, we are going to see how we pass from that approach to this one, which looks much more clean, easy to use, and it's super stable. We are using it at CERN in the business computing group in production applications and help us a lot to speed up the development process with more confidence. But yeah, and it also helps us to save some memory. This is based on some synthetic benchmarks analysis that we did, but more on that later. So before starting, I want to show you a little bit this little demo React component. This is using this use API hook that we are going to present today here. And basically, there are some mock requests that are that can be fired. And as you can see, we have the HTTP response body at the top. In the middle, we have the UI state, which is the thing that we really need to take care of when we fire HTTP requests in our React application, and some controls here to fire different kinds of requests with a predefined delay. So let's focus on the UI state here. Okay, most of you most likely are already familiar with the loading data error pattern. So here you can see that while the request is ongoing, loading state flips to true and then flips back to false, of course. If the request is successful, data is filled with the successful data retrieved from the server, and the error remains undefined. But in case we have like a request that generates an error, of course, we save the state of the error. In this particular case, this is an Axios error. And the data still remain the same as the previous request that was successful. So the latest successful request is still kept. This little approach allows us also to cancel in-flight requests here. And in this case, you're going to have a customized error and the data is kept. And this follows most of the patterns that basically use other framework and other hooks to do this, like Tanstack Query and use Axios. But let's get back to the presentation. So everything starts from the contract, right? The API specifications. These are basically used to make our server communicate to our client and vice versa in a structured manner, right? There are many tools that are based on these kind of OpenAPI contracts. One of the most famous is Swagger, of course. We can have a look. For example, this is an example of an OpenAPI 3.0 schema, and we can basically paste it, in a Swagger editor, and you can see that from this specification we can generate something, and then we don't need to know and understand all of the specification of the HTTP endpoint in order to call it, right? Everything is already there, is already written in the contract, so we can just try it out and just call it, We don't need to be aware of the method like the HTTP method, the parameters, the request body, and everything else. So it's quite convenient to use these things, but let's see how we can use it in our React applications. So there is a very famous open source library, which is called OpenAPI Generator, that is very widely used. It's super powerful and allow us to create the so-called API clients directly in the programming language that we are using. Since we are talking about React, this of course is in TypeScript in this case. We can have a quick look how this works. So we have our specification file here, all right, and we can simply run npm run generate APIs. And after a couple of seconds, yes, we're going to find something in our repository in the generated folders that looks like this. So there is a bunch of functions, interfaces, and types that basically represent both the model and the API entry points for all of our specification, right? As you can see here, the function is called fetch data, which reflects the content of the contract, fetch data, right? But let's have a deeper look into it. So let me switch back to the presentation. As I said before, not only the API clients are generated, but also the model, meaning that everything is type safe. And it's very, very convenient to have all of your type you have to deal with already generated in your front-end repository. Now, if we have a look at the first part of the operation ID, that's the name that the class is going to get. The second part of the operation ID in the API specs on the left-hand side of the screen is going to become the name of the method. And then we have the parameters to pass, all right? If we have a deeper look into this particular implementation of this generated API client, we can see that it extends by design a base API class. All right, what's inside that? The only thing we care about is the constructor that it provides. So in this constructor, we find the so-called API props that we need to pass to any API client in order to make it work. The first API prop is the configuration. This is normally used to pass all of the authorization and authentication things that we need. Bearer token, could be API token, even basic authentication is supported, every kind of authentication. Then the base path, which is very useful to have it as an argument that we can pass so that we can easily switch from one environment to the other or from one service to the other. And then we have an Axios instance. So this thing is a singleton instance of an Axios object that can be pre-configured with custom headers, configuration, interceptors, whatever we need to have set up in order to perform our HTTP calls. Nice. So let's extract this configuration URL Axios instance. Let's put it on the side for the moment, and let's go back from base API to the implementation, pet API, right? Now, imagine that we have a hook already available that provides us with configuration URL and Axios instance. We call it use API config. Now we can start building our component using the pet API the way I showed you before, which is the most common way of doing things. So first of all, we use the hook to retrieve these objects. Later, we instantiate a new instance of pet API, passing in the constructor what we basically have available here. And later we can use it, for example, awaiting the result of get by ID with custom arguments or that are defined somewhere else in the component. And this approach is actually quite stable, and it's decent enough for many use cases. And yeah, assuming that config URL and access distance are stable between renders, this is actually quite nice. But yeah, let's have a look at a simplified simulation, okay? How this would work in the real world. So we spin up our React application. We have a JavaScript runtime here, and there is a root component and the JavaScript heap. All right, it's very much simplified. So as soon as we mount our pet component, what happened in the heap? Well, we have a new instance of pet API created there, right? This actually works, and we can fetch our pet, we can display it correctly, and it's stable even if the application re-renders and all of the subnodes re-render. That is fine. So essentially, it's not a very bad approach, but what happens when the application scales, for example, horizontally, meaning that, I don't know, we have two elements now, two components now that use the same pet API? Well, you can see that with this approach, we have a copy of the same object in the heap that is occupying memory for no reason. We should use a singleton, right? Anyways, it will work. It will not create problems, but it's just maybe not the best way of doing it, right? So let's focus now on some of the weak points of this implementation. First of all, we have the use of, memoization can also not be implemented in this case, but if you want a stable result, you could definitely. But this introduces a lot of boilerplate, right? So maybe it's not ideal because developers can even forget, and they think that maybe their component is stable enough, but when it gets re-rendered, new requests are fired, right? So not very ideal. And the elephant in the room, as I said before, is the use of new instances every time we mount one of these components, right? So let's focus now. So now we are going to have a look at the reasoning behind the approach that we proposed. Okay. So the question that we try to answer is what identify in a unique way an HTTP request using OpenAPI specifications? Well, first of all, the API client itself, right? And we put it here. Second, we need to identify the method of this client that we need to call. And we put it here. And later, the arguments to pass to the method. So these allow us to fire a specific request to one specific endpoint without taking into account any specification, the HTTP method and everything that I mentioned before. So we call these request dependencies. Keep this in mind while I put it on the side for the moment. And let's focus on a second part, which is interesting, which is the UI state, right? The request state, what we want in our component to manage the workflow, right? The lifecycle of our components in our React app. This is basically what you saw here. Loading, data, and error, right? So more specifically, loading represents the state of fulfillment of the underlying promise that is created every time that we fire an HTTP request. Data is gonna contain the result of the server only in case the request is successful, and error is gonna contain the Axios error in this case. With all of the specifications, everything that we need to know about what went wrong, right? Now, we can run It's very simplified simulation of the communication client server. So we have our pet component that is about to get mount. So it gets mount, and the loading state flips to true. There is a spinner here. Oop, sorry for that. There is a spinner there that you can see. And as soon as we fire the request, it gets to the API REST server, and the server loads the data correctly, in this case, right? And the data comes back. And when it's back to the component, well, first of all, the pet component can display the data. And if you have a look at the request state, we have that loading flip to false, and data now contains the latest successful content retrieved by the server. Case of an error, it's gonna be most likely like this. All right? Now, let's keep in mind both the request dependencies and the request state. We put it aside, and then we go from the previous approach discussed before to this. Just one hook call. Much more cleaner, no? So what are we interested into here? We wanna have the UI state, right? The request state. So this is the return. So this is what's returned by the hook, right? And then we want a way to identify one unique HTTP request. So we need to pass API client, method, and arguments. And we pass it here. Now, we can do a couple of considerations here before we move on. Yeah, you can see that API factory doesn't exactly take an API client object that you can instantiate. And this is quite convenient because OpenAPI Generator actually provides these factories that basically encapsulate all of the logic to retrieve objects to perform HTTP calls with singleton methods. So it's perfect, no? The method name is a string here. And one could argue, well, a string is not really type safe. But in this case, it is, because the string that you see as a method name is checked against the keys of the pet API factory. So it has to be something that is a key of the pet API factory. You cannot write a random string, and the modern IDEs suggest all of the possible strings that are accepted, all of the possible methods. And then we have request parameters, all right? We can directly pass them here, and the request is fired as soon as the component is mounted. Now, do you see any disadvantage in this approach? Well, I see one, which is the fact that at this stage, we don't have the possibility to fire subsequent requests, all right? So to basically mitigate this issue, we included an execute function that you can see there. Basically, execute can be called anytime with every argument subsequently. And since it is completely like a separated reference to the function that is actually getting called, you can use it in a declarative way, imperatively, as you wish, basically. And then we can pass another argument to basically prevent the component to fire the HTTP request on mount. And this is manual. If manual is true, of course, we don't send the request. That is very similar to the use Axios hook, if some of you have experience with that. And let's move on. We provided another attribute here. What is this backend? Why? Why do we need that? Well, let's focus a little bit on that. So, if you remember what we discussed before regarding the API props, was that we need to provide a configuration, an URL, and an access instance, right? But imagine that our React application consumes multiple different services that require different authorization, different, I don't know, Axios configuration. Well, in this case, it's much better to provide it as a map, all right? So that, in this case, this simplified example, we need to basically communicate both with the pet application and the user application. We have two different set of API props there. And we can just check whatever, we can just set whatever we need to call by writing this here in this parameter. But of course, there are like default configuration that you can use to just avoid to write this every time. So you can just define the default configuration that you want to use. So the API props map is passed to a provider. Why is that so? Well, because we want to use reliably our useAPI hook anywhere in our application. And to do so, the React way of doing it is just to provide some providers, right? Some wrappers. So imagine that now we have the pet component and the user component. As soon as they are children of OpenAPI provider, then we can use usAPI as you saw before, very conveniently. So now let's focus on the two key pieces, okay, of these presentations. So the usAPI hook and the OpenAPI provider. Well, we extracted those and we basically distributed them as a library, which is now in npm. So I advise you to try it out and check it out. It works very nicely. And before finishing, I want to touch on the performances. So during the implementation, we were wondering, are we actually saving some memory? Can we measure the memory allocated by the browser page in the two different scenarios? So what do we have here? The line in blue is actually an application that spins up a lot of components. So, sorry. In the x-axis, you can see the number of components that are mounted at the same time in the same web page. And on the y-axis, you can see the memory that is allocated by such page. And yeah, the blue line represents the approach using our custom hook, all right? While the orange line represents the approach using the new instances of API clients. We saw some interesting things here. Well, first of all, for small application, which is the case for most of you, I guess. So if there are less than 100 components, let's say, using our hook over the other approach, the difference is not going to be noticeable, right? But if you have a very large application, which is already like a exotic case, I would say, that has between 100 and 250 components, well, it looked like usAPI hook managed to save a lot of memory. And in extreme cases that probably will never happen, so between 250 components and 350 components, something interesting happened because the use API hook doesn't perform as well as the new instance of API clients. Why is that so? Well, of course, use API comes with a little bit of memory allocation for each request because we save the state for every single request, right? And most likely, we do not have a definitive answer to this phenomena, why this happens, but we speculate that the garbage collector is smarter in basically collecting all of the new instances that are created, and the state is not actually collected. So in these extreme cases, creating new instances is actually more convenient. With that being said, yeah, I advise you to try this thing for your React projects if you'd like. You can find the open source repository for this in the CERN GitHub space. And there is also a very simplified example that uses this to basically create a simple web application. But very soon, I'm gonna also publish this one, which is much fun to play with. With that being said, well, I wanna thank all of the contributors for this project, especially Martin, Tanio, and all of the CERN's business computing group for supporting me on this project and on this presentation. So thanks to them and thanks to you. I'm glad that you came to attend this talk. And if you have any question, I'm ready for it. Yeah.
Can you explain why there's no benefit in low usage?
That's our intuition is that it depends on the browser, most of the cases, and our intuition is that there is a certain amount of memory that is all of the time occupied. It's like reserved, and with the tools that we use to inspect the memory allocation, that portion of memory, no matter if the page is like empty or not, they basically they don't allocate extra memory for that. So the real difference is when you spin up like a bigger application with more functionalities that, for example, has hundreds of components to render. Yeah.
I have a question about the number of components, right? So how did you actually measure, like, so you created artificially a large number of components, right? But in a normal application, usually you have a lot of them, but they're just like super nested, right? Does that maybe impact the performance of your use API too? Did you think about measuring that as well?
Okay, I repeat the question. Sorry for not repeating yours before, I forgot. So the question is, actually, the way we measure the impact of memory is correct. So what you said. So we mounted all of the components one on top of the other, but we didn't measure the performances gain that we could get with nested components. So it's something that is very interesting and we could explore for sure. But for the time being, we didn't. And I mean, we needed the proof, a simple way to test that our approach was actually useful to save some memory. So yeah, of course, we can do further analysis and could be interesting, but yeah, I have not an answer for that right now. Thanks. Yeah.
So for the same endpoint, the same API, I trigger multiple requests for the same operation ID. So the state will be loading for the first request, and I triggered 100 number of requests at the same time. So how the component will behave in this case? Will it
The operation ID you are referring to the OpenAPI specification file? Yeah, so basically in the OpenAPI specs, you have a list of operations that have an ID and like an identifier which identifies the API client and the method itself. So every single different request has a different footprint.
Same request. So for example,
Yeah.
pet ID. So I'm triggering it in multiple components.
Yeah.
So maybe part of a page on the left and right, I trigger at the same time.
Yeah.
So what will happen if the loading state will be updated for the ID or
Nope, because every time you use API, so in the case of multiple pet components, let's say, that are using use API simultaneously, what is gonna happen is that there is some space allocated, like a state allocated for every usage of use API. All right. So this implies that all of the UI state that you need to take care of, it's isolated. So you can actually use it, all right? There is gonna be a loading state, a data state, and an error state for each one of the times you're using use API. Correct, yes.
also is that in the same context, is there a way to abort a request like it's the same request with the same ID is already going on? So how can I abort a request?
How can you abort the request? Yeah, so I didn't show it in the presentation, but we actually provided a new version of the library which exposed the abort function, the cancel function. I can show you here. So this is our component. And we have loading data error response because data is only what we retrieve, while response is the Axios response, which carries the status code and other insights. And we have fetch and abort now. Actually, this abort also honors external signals. So even if it comes from somewhere else, you can use the same signal to abort a request which comes from use API. Yeah, thanks to you for the question. So if you have other questions, I guess I need to move now, so you find me here. Thank you again.